We begin with a long journey to the European Southern Observatory, which ironically is based in Chile in South America. Will Goodbody has been there to see the ongoing work.
It's known for many things, including its capital Santiago, its extreme landscapes and a turbulent political past. But among astronomers, Chile means just one thing. Because the north of the country, which is partly covered by the Atacama Desert, has exceptionally clear and dark skies, offering stunning views of the centre of our Milky Way galaxy and the two dwarf galaxies, the Magellanic Clouds. And so the European Southern Observatory, or ESO, Europe's foremost intergovernmental astronomy research organisation, has built a number of observatories there.
We operate 4 observatory sites in Chile, which have been added over the 50-year history of ESO step by step. Okay? The first one is called La Silla, founded almost 50 years ago. And the second one in time is Paranal Observatory, where we are standing here, and we call this our flagship. Then we have a couple of newer telescopes, which are radio telescopes, observing radio waves. And then our facility number 5, which is not yet existing, but it is basically under construction, is the extremely large telescope, which will be finished hopefully by 2024, and will by then be by far the largest optical telescope on Earth.
Paranal is home to 2 telescopes for surveying and mapping the sky, as well as the appropriately named Very Large Telescope, or VLT. It's actually made up of 4 huge 8.2 metre wide optical telescopes and another 4 1.8 metre wide auxiliary telescopes. They can operate independently, or the light they gather can be joined together using an interferometer to form one massively powerful eye on the sky.
In our solar system, there's something like there are 8 planets plus Pluto, the dwarf planet, but obviously in other solar systems, in other orbiting other stars, there are other planets. What we do, we look at the star, we occult the light from the star, we block it out, and when we block out that light, we can see tiny specks of light, and these tiny specks of light are extrasolar planets. We also can determine what the atmospheres of these planets are like, and in the future, maybe in a not so distant future, the idea will be look for things like ozone and signs of life on extrasolar planets.
Paranal is like an oasis of science deep in the Atacama Desert, a self-contained working village with its own residence where the astronomers and technical staff sleep and eat when they are on site, and which featured in the James Bond movie Quantum of Solace. There's also a gym, workshops, power plant and more. It operates around the clock, with maintenance carried out during the day while the astronomers sleep, and stargazing at night when they are awake.
At the moment, I'm currently working a full night shift. So my day starts around maybe 5 p.m. I come up to the telescope for sunset around 6:30, start working and go all the way through until 5 a.m., 6 a.m. in the morning. Head straight back down and then do it all again the next day.
We discuss, we analyze how the night is, because every night is different, how the conditions are, and we decide on a program that we want to do, a special type of observation. And then we start moving the telescope to the desired position and start taking data.
While the VLT is big, not far from Paranal, ESO is planning something even bigger. At the top of this mountain, the European Extremely Large Telescope will soon be built. With a mirror the size of half a soccer pitch, it will be the largest optical telescope in the world.
Here we are driving up to the Chacnantor Plateau. This is the site of Yalma Large Millimeter Array. This is the place where the antennas are.
Much further inland from Paranal is the ALMA Observatory, situated at a dangerously high altitude of 5,000 metres on a plateau high in the Andes. It is an array of radio telescopes, 66 very large mobile dishes which can collect light coming from some of the coldest parts of the universe. The environment is exceptionally harsh. Workers must often use supplementary oxygen, while without protection, skin burns in minutes. So most of the work is done from the support building further down the mountain.
It takes about 3/4 of an hour to travel from here to the high site, to the 5,000 meter site. It's a dirt road, and it's often, we have problems with winds and things like that. So it's a challenging site. It's challenging also because it's of course very cold at altitude. We have 2 large vehicles which can lift the antennas up and transport them from one place to another. We have just under 200 different antenna stations dotted over the plain, on the Atacama Plain, and we can put an antenna down on any one of those 200 stations.
The location was chosen because water vapour distorts light signals, and this is among the driest places on the planet.
They are extremely good for basically looking at things that are forming, like galaxies forming, planets forming, stars forming. So millimeter wavelengths see through all the dust that obscures the optical and infrared, and you can see right to the core, and you can see, you know, what's happening right at the center of these dark clouds. So it's extremely powerful in that respect.
Right now, Ireland isn't one of the 15 European states, plus Chile, that are members of ESO. The government is currently considering joining, which would cost €14 million plus an annual fee of €2 million. But astronomers here say it would be worth every cent.
I would be optimistic that it will happen eventually. Ireland is almost unique within Europe at the moment as not having access to the European Southern Observatory. And because of that, it excludes us from carrying out frontline astronomical research, and also it excludes Irish companies from bidding for European Southern Observatory contracts.
While those talks continue though, so will the discoveries at ESO's facilities in Chile. As astronomers deepen our knowledge about stars, galaxies, exoplanets, black holes and more, and attempt to answer some of the most fundamental questions about the universe and our tiny place in it.